Hey guys, it's me. I'm gonna teach you guys how I was able to solve this normal stress problem. Now what I did was I used moment. Why? Because there's a hinge, and when there's a hinge, you got a moment. Well, at least if the hinge is connected with everything that you need to solve. If it isn't, I think I don't know how to answer that. Who knows? Maybe we'll figure it out. Anyways, what's the given? We are given a area of cross-sectional area of each cable, which is 0.017 inches square. We're also given the weights of the tailgate and the weight of the crate. What are we supposed to find? It's asking us to find the tensile force, which is T, by which and also the normal stress, which is this thing. And the way you get this thing is you need to do this thing. Side note, since tensile force T is a force, we can relate it to P, which means this is how we'll be able to get the final answer. So how do we get P to get D to get this? We moment. And as I said, where should we moment? Should we moment here or here, there, everywhere? If we moment here, over this thing, that thing, and this thing, and those things, we don't want that. We'll lose all that. We'll lose what we needed. If we moment here, we'll just lose this thing, that thing, and that thing. But all the things that we need are still intact. So that's why we'll be momenting at this hinge. Summation moment. I just like the name. I just like doing this. You don't need to do that moment. Let's start with the cable, since it's what we're trying to find. Tensile force of each cable. And since it says each cable, that means there's two cables. There is two cables, so that's two. Trust, which is a cable. And then since it's slope, we need to find the Pythagorean theorem, the resultants. How do we get the resultants? Like I said, a Pythagorean theorem, height times length, width, which is just 16 inches squared. That's 20, I think. What's the x value? 16 divided by 20, that's 4/5. What about the y values? That's 12 or 20, that's 3/5. Now, which one of these values are we going to use for our resultant of as the resultant for our cables? Now, let's go back to the figure. Which way does the hinge move? Since we are momenting at at this hinge, how does it move? Does it go left to right? Or does it go up and down? It goes up and down, so we'll be using y values, which is just 3/5. And then its length away from the hinge, which is about 16 inches. And then on to the next one. But before we do, I just want to say, side note, I guess I assume that it's a tensile force, and since it's a tensile force, I mean a tension force, meaning it's pulling away from the joint, and since it's pulling away from the joint, it rotates counterclockwise for the hinge, meaning it's positive. And the reason I said that is so you would know why this time with the tailgate is negative, not because it's the y values where up is positive and down is negative. It's more because of the way it rotates to the moment or from the moment, I guess. It rotates clockwise, therefore it's a negative value of 60 pounds with a length of 14 inches. Gotta be careful of how you understand these units, just these given values, because sometimes it can be confusing. Like, what does this mean? Is this DR? Turns out it's the distance of the tailgate. Why is there a tailgate here? Why don't they just write it out? That's tailgate. Exactly, I know, right? Anyways, let's go on to the next one, which is the crate. It also goes down, so clockwise, negative 150 pounds. Now, what's its distance? Is it 16 inches or 14 inches? It's 18 inches. I got confused too. I thought that was the diameter of the cable, but if you look closely, you'll notice that there's arrows pointing in, in between, meaning this one's actually just distance of the crate away from the hinge. I thought it was the diameter at first, but that wouldn't be making any sense because problem already gave us cross-sectional area. So there will be no need for a diameter. Yeah. So now we simplify. First, we move all these negative values. Well, not because they're negative values, but because we need to isolate this equation. So to isolate this, all we need to do is just transpose those that do not belong with this equation. So that'll be 3/5, 16 inches equals, let's solve it already too. That equals about 50 pounds per inch. Next step, E equals 3540 pounds per inch divided by 2, 345, 3/5, 16 inches. Don't be confused. This is pounds and this is inch. Inches. Cancel out the same terms. That'll leave us with 184.375 pounds. That's the tensile force. Now that we found the tensile force, remember T equals P. We can now solve for the compression, the normal stress of each cable, which is just inputting what we have already. And the cross-sectional area, there you have it. So each cable is carrying about 100, and we have about 10,845.59 pounds per square inch. I mean, you could make kilograms by dividing it by 1,000, will then become 10.85 k KSI. Is it? Yeah, but I don't want to do that. Entire units are in pounds and inches, so I'll keep it in pounds per square inch. Anyways, that's how you get this answer.